Hi everyone, my name is Tomas Dersjö and I work at Scania IT specifically, and this is our partners, Agile Lab.
Hi everybody, I'm Alberto Firpo, CEO and co-founder of Agile Lab.
Okay, and so today's topic then, Scania's evolution towards data mesh. The agenda or the train of thought that we will follow is this. I'll try to first set some context to what the transport ecosystem is going through, and then explain why I personally think that data mesh and the principles that it's based on is such a good fit to Scania and our legacy and what made us successful historically and up to date. And then we'll hand over to Alberto to highlight a few key aspects of data mesh specifically. So where is Scania today then? Well, we have an offer, a truck predominantly, which is based on an internal combustion engine to a large extent. It's modular and it has clearly defined interfaces and performance steps. And that is closely connected, and the properties of this product, to the business model. And this used to be in our annual reports up until 2016. And you can see from the business model that we keep fairly good track of our customers' total operating economy. And that's sort of the focus of what our product and our product properties has to be. So this has sort of guided us, knowing that our customers cannot make money unless they're moving goods. So uptime, highly important. And then you can see the cost mass of a typical customer, where 2/3 are actually driver and fuel consumption. So it's fairly easy to deduct that if you have a product which has superior fuel consumption, you can offer something unique to customers. And where are we then today? Well, since 2016, we've won the Green Truck Award 5 times. And it's not because they're electric, which you might have assumed, it's because they have superior fuel consumption. So currently, we're able to provide a pretty good total operating economy for our customers. Where are we heading then? Well, autonomy, connectivity, and electrification are sort of the major trends in our area. So we're going from ICE to ACE in a sense. And you can understand that if there are no drivers, 1/3 of our customers' cost mass is gone. So whoever legally can drive autonomously is going to attract a lot of customers. Electrification-wise, that doesn't reduce the entire cost of propulsion, but it will significantly reduce it. So it also takes away what I would claim is our unique selling point currently, which is a bit of a hassle then for us in a sense. It's good for climate, but it poses a business problem, you might say. Luckily, we're quite good at connectivity and the data that brings. So if you go to our website today and look at our products and services offer, you will see this. You will still see a lot of, let's say, ICE-based offers, but there are some battery stuff, some urban transport solution, and we actually offer services, data-driven services today. This, though, will have to increase the revenue streams from here, the services we add on top of our truck, for instance. We have to get better at. And this business model, who is in our annual book reports now a lot fluffier, will probably turn into multiple business models, which then, again, should be concretely tied to properties of data or products. And then, what do we do then to develop data-driven services, for instance? Well, I would like to explain my view on what made Scania so successful historically and how that ties back to the principles of data mesh. And we will start with data as a product, because historically we've been quite good, I would claim, at defining product properties that have very clear relation to our customer's business. So we've known what properties our products need to have and how that affects our customers. And if we can view data as a product, and define the properties that these products need to have to make our consumers or customers, depending if it's internal or external, then I think we'll be fairly successful going forward as well. And an example here is if you're an Italian, for instance, and you have a fleet driving in the Alps, you need certain performance. You need something out of the product. And then you can combine some modular components, products, into a new solution, more or less tailored for you, which is what this modularization image represents then. And reusing data products, not just for one use case, but combining it in multiple ones, will be quite key going forward, we think. I will stay mainly on the right-hand side here, and I'll leave it to Alberto to highlight some of this and deep dive into that side. The next portion is then who develops these products? Well, currently, it's very clear who owns each of these systems. So they have complete responsibility of the performance of that product. And the product managers are fully responsible for the uptime, for the cost of that, and so on. Now, mapping that over to data, establishing domains where you as the domain expert also develop data products should be doable. And then you can have, if you go to another homepage of ours as a customer, depending on your needs and your operation, you can then combine components or products into something that you will use for your business. So this is available for the hardware product, let's say, but this could very well be a data catalog, for instance, in the data world going forward. What next then? Well, the self-serve data infrastructure as a platform. For the hardware product, we have a lifecycle management platform, which as a developer, you can play around and do whatever you feel like. But if you publish something to our product structure, to the modular product structure, you adhere to certain standards and protocols. So you cannot screw up our modular structure. Then you will get repercussions, I would claim, in Scania. And similarly, and then what that allows is if you publish, for instance, your design here, then others can add value on top of that. In this instance, it's various types of simulations. So for instance, this person here is simulating disassembly. And we sell repair and maintenance contracts. So the quicker you can repair something or maintain it, the cheaper we can offer those contracts to customers, and then we can skim a little bit of that and make money ourselves. If we're cheaper than Volvo with this, and we offer cheaper contracts, all the better for us and the customers. And that's based on publishing stuff according to standardized interfaces, for instance. Last one, federated. I shortened it. It's actually computational governance for those of you who've read the sort of original write-up. But I've said federated governance here. There are structures like this as well existing. The product managers I referred to earlier, who are responsible for engine, for drivetrain, for cab, and so on, they sit and meet. They know each other fairly well, and they meet fairly often in a council. And they update the process that they work in. So they own that. And then there's a small central team. There are roughly 800 engineers working in this process. But there's a team of 4 who upholds sort of the principles and the standards based on input from those working in it. And this is now the most aesthetically appealing image, but these stars down here, those are sort of, I would say, communities that deal with certain aspects of this process. And then whatever they feel needs to improve is lifted, and then, then decisions and updates continuously can be done. And then you adhere to those. So that allows for autonomy within domains, but in a way so that you can still maintain your modularity and reusability. So this is why I think data mesh is a good fit to our company culture and our legacy and what made us successful so far. Now, when implementing data mesh, there are some things to keep in mind, and I will leave it to Alberto to highlight some key aspects if you're keen to do the same.
Thanks, Thomas. So basically, I would like to give you some hints regarding the basic shifts that the data mesh introduces, generally speaking, and also in the context of Scania. Well, in 10 minutes, I try to be brief. So first one is from the organizational perspective. I would say that in a traditional organization that mostly is the representation of what it is right now in Scania, you have business units on the upper level interacting with the IT people. And generally speaking, is working like this also in Scania, centralized team of data engineers. So in this way, as you can see, there is a huge friction between business units and the rest of the IT teams. And generally speaking, this introduces a couple of problems. So first of all, having intermediaries in this kind of flow from a single business unit towards to the data team, obviously it means having many intermediaries, and so process lead time is not the well expected, as expected by the business stakeholders. So they want to iterate fast and have fast time to market. And it usually happens that business units want to be independent in some way and to solve their data problems on their own if the IT team is not responsive enough. And this is something that is happening a lot. Then on the other side, we have languages problem or jargon problems. So it happens a lot when there are many business units, so many different domains that are complex domains compared one to another. So if we stick into the Scania organization, we are talking about finance, sales finance generally speaking, so basically loans and leasing, which is almost a bank, and it is a core process over there. We have also sales and marketing, we have hardware, Thomas has shown before, which is very complex, connectivity, telematics, and so those domains are very different one from another. Basically, they could be considered a company, in some cases in other kind of environments. And so for a single data team that is central, learning the jargon of the domain jargon of every kind of business unit is very complex. And that is this friction, this fracture in understanding the language affects a lot the modeling, and affects a lot also code and also obviously data. And well, at this point, code and data are the main part of the software. So this friction falls a lot into the data as well. And so these are the main problems that basically the data mesh is addressing, particularly from the organizational perspective. And so this is very important because when you are doing a data transformation, data-driven transformation, generally speaking, and you have all the organization involved, because we don't want to create yet another silo. We want to embrace all the units in this kind of transformation. Having an organizational approach is a good answer. Obviously, I'm not saying the data mesh is good for any kind of company in the world, but if we consider the Scania footprint as a possible identikit, we could identify a company that works with many business units, complex domains, international footprints, and then a centralized IT team. This is mainly the identikit that fits well with this kind of data mesh answer. So what is the answer? So precisely, few words. Shifting the ownership on a specific domain, business domain, with a cross-functional team, so that it's vertical, and each specific domain must have all the competencies inside in terms of data engineering and all the DevOps teams, SysOps teams, and so on. So vertical approach, atomic with each domain, but with a way to communicate and to distribute data from one domain to another. And then the federated governance that also Thomas has said before. So the IT team, central team, is not in charge to make anymore, but just to define and control in terms of policies and standards that must be distributed in a federated governance kind of way. So, organizational perspective. Then, jump into the data as a product view, very brief hint regarding the data product or data as a product, which basically is the core. So is the fundamental piece to build correctly a data mesh. So consider the data product as the brick to build, the whole data mesh ecosystem. And so basically from the domain-driven design, kind of style of modeling, the data product could be considered as the perimeter solution that we have to solve the problem for a specific problem that it has been modeled in a specific subdomain and generally speaking in a domain. And so into the domain-driven kind of jargon, it means data product is the binded context of the specific problem. What's into the data product? We have mainly different kind of features. We have obviously data that must be persisted into the data product. We have code, we have infrastructure, we have workloads, but we have many other kind of things that are informations that are around the ecosystem in terms of information that we need to provide and to bind into the specific data product. And then we have a process around the life cycle of data that we want to be binded as well into the data product. And so basically I go very rapidly into the, I would say the features that we are addressing in Scania as well. So obviously ownership is very important. Obviously we need to understand very clearly who is the data product owner. Obviously for obvious reasons we need to identify the right person for the specific data product in the specific bounded context and domain. We have information management features, like for example, freshness, how we update the data inside the data product, metadata, schema, lineage, and so on. Versioning, which is very important. We can talk a lot about versioning, but we don't have the time today to do that. So data consumption features, very important for data consumers. So immutability, read-only access at the output port, time traveling, and so on. Observability features, like for example, downtime. Data product is self-deployable, so it has dedicated resources on top of specific technology which is binded on. And so we need to, stick with this kind of reference which is directly connected to the resource that the data product is allocated to. And we can give directly downtime, so giving transparency to everybody. Observability features as more other stuff like data quality and so on. All those kind of informations, so information management, data consumption, and observability are very important and must be binded to the specific data product because we want to have the maximum level of transparency. And we need to bind all those features directly to the data product. But we have more other features all around that are more connected to the process. So the life cycle creation of the value around the data product. So basically, we have, for example, business informations, documentation, we have question and answers, we have the usage, the reviews of the usage about all the data consumers around the specific data product. All this information must be binded as well. Then we have the process itself. As the title says, data as a product means that now we need to think about product and not specifically project. So it means it's a totally different way. We are in a kind of marketplace. So me as a data product owner, when I receive a change request, I need to first to understand my market. I need it, my market need it or not. Otherwise, we need to think differently to what I need to implement into my product because it's my ownership to maintain the product and so on. And this is a very important feature because we need to maintain quality for the data product owner over time. And this goes directly into the system of billing and incentives. Because actually, as a data product owner, I must have an incentive of what I'm doing. Otherwise, we have a lot of documentations in every data lake environment everywhere, but nobody is seeing that. And if we want to have quality, binding all those information of data products, I must be incentived from the economical perspective and also from the reputational perspective. And there are many ways to do that. That stick into the building kind of process. It's a long discussion and I'm running out of time, so if you want, we can go deep on it. So finally, to conclude, in my last 30 seconds, when you have to build a data mesh initiative, many people are trying to address that use case driven. It's good to have a subdomain to start with, but we need to have the whole picture. We need to build the overall self-service platform. And I would say the three main components to do that are scaffolding templates that allow us to be interconnected to the specific technology. Then data product provisioning, there is a lot to do in terms for this specific feature. And the data product marketplace, which is very important, and it's not a data catalog, just to avoid misunderstandings, but it's the point where we need to have those information that I have talked before in the previous slide, all binded in a single place. It is very important because we need to fulfill all those information for all the data consumers that are in the community. Run out of time, sorry, I've been a bit longer, and actually there's a lot to say about data mesh. We expect you discussion on our booth. Thanks for listening.